Welcome back to your favorite YouTube math lessons. Today we're going to look at exponential and log equations. So we're going to kind of put together all the rules and properties that we've learned and actually solve for some variables, which I think is a little bit more exciting than what we've been doing. So with all the rules that we've learned, we can solve problems like these. We have 2 to the power of 5x plus 1 is equal to 32. So this is a little bit new because we have variables that are exponents, which are a little bit harder to solve for. So there's two ways that we can do this problem. One that we looked at briefly earlier is that if we have the same base, there's a rule over here it says, if we have the same base, then exponents are equal. So if I have 2 to the power of 3 is equal to 2 to the power of x, then I know that x has to equal 3, because if the same bases are if we have the same bases, then the exponents also have to be the same. All right, so let's look at this problem. So if I can get both of my bases to be the same, then I can make the exponents equal to each other. So I think 32 I can change to a base of 2. Let's look. I believe that 2 to the 5th power is equal to 32, and it is. So I can change this to 2 to the 5th power is equal to 2 to the power of 5x plus 1. So since I have the same bases, I know that 5x plus 1 must equal 5. So we have the same bases, so my 5x plus 1 must equal 5. And this is a really easy problem to solve. To get x by itself, you have to subtract 1 from both sides. So if I subtract 1 from both sides, I get 5x equals 4. And then the last step would be to divide by 5. So if I divide both sides by 5, I get x is equal to 4 over 5. So remember this rule here. If we have the same bases, then exponents are equal. There's another way to solve this, though, which some of you might find easier, some of you might find more complicated. If I have this problem, I can take the log of both sides. All right? So I'm going to take the log 2 to the power of 5x plus 1 is equal to the log of 32. Hopefully you guys remember that if there isn't a number here for the base, it's just 10. So you can put a 10 in there if it makes you feel better, but it's just it's a 10 there. All right, now if we have a log, and inside of our log we have an exponent, hopefully you remember that we can take this exponent and bring it out here. So we have 5x plus 1 times log of 2 is equal to log of 32. So now I got my x out of the exponent, which makes it a little bit easier to solve. So now if I want to solve for my x here, I need to get rid of a couple things. My goal is always to have x equals something. So I need to get rid of this 5, I need to get rid of this 1, and I need to get rid of this log 2. Now the rule usually is we want to get rid of everything farthest away from the x first. So I want to get rid of this log 2 first. Now my log 2 is multiplying times this. So to get rid of my log 2, I can divide by log 2, divide by log 2. And it'll cancel out on the left, and on the right, I get log 32 over log 2. And we can use our calculators to figure out what that is. So I have log of 32 divided by log 2, and it's equal to 5. Notice the calculator changes it automatically to base 10 to make sure that's what you want to do. All right, so that's equal to 5, so I get 5x plus 1 equals 5, which is what we had in the last equation, right? So once again, we subtract 1, we get 5x equals 4. Divide by 5, we get x equals 4 over 5. So if you want, you can change this to have the same base as the other side, or we can take the log of both sides, whichever one's easier for you. All right, next up, we have the log 5 minus the log 2x is equal to 1. All right, so we have to use some of our properties that we learned before. Hopefully you remember that if we have the same base, here we have the same base because it is base 10 and base 10. And if we have subtraction, we can change this to log 5 over 2x is equal to just 1, not 10, is equal to 1. And this is log base 10, right? Now I can change this to exponential form. Remember, we learned left to the power of the right is equal to the center. And this only works if the log is on the left side. So if it's on the left side, we need to change our equation so it is. So the number on the left is 10 to the power of the number on the right, 1, is equal to the number in the center, which in this case is 5 over 2x. Now I know that 10 to the first power is just 10. So I'm going to erase that 1. So 10 is equal to 5 over 2x. So we need to solve for x, which is down here in the denominator. Now if we have a variable in the denominator, we can't solve for it. So we need to get it out of the denominator first. So to get it out of the denominator, we need to pass it to the left side. To do that, we can multiply by 2x, and it'll cancel out on this side. Multiply by 2x over here. So it moves over to the left side. So on the left side, I have 2x times 10, which will equal 20x, is equal to 5. Now, to get x by itself, we just have to divide by 20. Divide by 20, and we get x is equal to 5 over 20, and we can simplify that down to 1 over 4. All right, last question, we have a word problem. Everybody loves word problems. So it says here, Mr. Wilmus invests $1,000 in an account that compounds interest annually at a rate of 8%. How many years will Mr. Wilmus have to wait until there's $10,000 in the account? All right, so we learned earlier in this chapter how to make equations with compound interest. Hopefully you remember. So we have y equals, the equation is our principal amount, which is $1,000, times 1, and it's either plus or minus depending if we're gaining or losing. In this case, we're gaining, right? So it'll be 1 plus 0.08 times the number of years, or in this case, we can put x. All right? The packet that you guys did kind of changed things around a little bit. So the value is equal to our principal amount. I'm going to change this to 1.08 times t, which is time, or in this case, years. So I want to figure out when I'm going to have $10,000. So to do that, I can plug in $10,000 here for my value. And now we have an equation. And in this equation, we could solve for t. So how do we want to solve for t? Well, we can do it a couple different ways. I think the easiest way is going to be similar to what we did here, in this problem and take the log of both sides to get rid of the variable that is an exponent. So to do this, first we want to get rid of this 1,000. So we get our exponent all by itself. So this is 1,000 times this, so I can divide both sides by 1,000. And 10,000 divided by 1,000 will equal 10. So 10 is equal to 1.08 to the power of t. All right, so now I can take the log of both sides. Make a little more room here. So I'm going to put down the log of 10 is equal to the log of 1.08 to the power of t. Now we learned before, if we have the log of an exponent, we can move our exponent to the front here. So we get log 10 equals t times the log of 1.08. So to get t by itself now, we can divide both sides by the log of 1.08. I'll cancel out over here. Log of 1.08. So that's gone. So we have t is equal to log 10 over log of 1.08. So I can use my calculator to figure that out. Let's see here. I don't know if you know this function with a calculator. This might be a little bit shorter. We can copy this by clicking on enter and then just change my numbers around. So we want the log of 10 divided by the log of 1.08. Those both have base 10, right? Hit enter and we have 29.9188. All right. So 29.9188 is equal to t. And that's in years, right? So about 30 years. It'll take me for that initial $1,000 investment to reach $10,000 sitting in an account untouched. Hope you enjoyed the lesson today. Please bring any questions to class. We'll see you there.